This is the overview presentation for the Administrative Shell Scripting course. In this presentation, we're going to cover the kinds of things we're going to deal with in this course and talk about how we're going to cover them. In particular, we're going to define what scripting is, what it means to us, and what we do when we do scripting. When we give commands to a computer to make it do things for us, we normally enter them into a terminal type window. We're entering them actually into a command interpreting program. And the most common programs we use for that are called shells. And in particular, we tend to use only one shell for a particular operating system. The commands that we enter are general purpose. We can make the computer do anything we know the commands for. If we take those commands and save them in a file so that we can execute that list of commands in the file at some future point, we call that scripting. So writing scripts is simply a matter of putting commands in files as if we were going to type them on the screen. Lots and lots of interactive command interpreter programs can be run using saved scripts. We're going to be using bash in Linux. We're going to be using PowerShell in Windows. There are only two examples of interpreter programs. Any program that can interpret the commands you give it and act on those is known as an interpreter program. When using scripts to run these commands, the general rule is that these commands that are saved in the scripts are the exact same commands that you would type on the command line. And any commands you might type on the command line, you could just save in the scripts the way you typed them, and they should continue to work the same as if you typed them on the terminal window. So it's a way of saving commands to run them again later. You may then ask, why would I bother to write a script? The main purpose for writing a script is to create a tool, something you can use later or someone else can use later. The idea is that the intelligence to do the task, the knowledge, the skills are built into the commands that are in the script, allowing a user to do those things whether or not they knew the commands to do them. Ideally, a script will communicate the status of a task and the requirements of a user to that user and do it in a way that the user can understand and work with. Scripts should always perform the checks necessary to ensure the task gets properly run and to deal with problems that may arise when the task is carried out as requested by the user, because things do sometimes go wrong. Different systems are run different ways and maybe in different states, and not every task is going to run the same on every machine. Scripts need to be able to deal with that. There are a number of things that we get from scripting beyond simply saving commands for later use. They don't introduce any new abilities. You're not going to be doing anything in a script file that you cannot do on the command line. So you might wonder, why would I bother to do this? Why wouldn't I just save my commands in my head? Well, the number one reason that we do this for our own purposes is usually to avoid human error. We have errors in entering the commands. We have input from a user who runs our commands, even if that's ourselves, who may well have typos or other issues in their user input. And of course, we want all our commands needed run every time we run them, and always in the same order. Complex tasks can be simplified. Instead of having entire sequences of commands to remember to run, we can reduce them to a single command to run. Saves time and avoids errors, trouble, and problems forgetting things. We allow our scripts to do queries on the system so they can handle multiple platforms that they might run on, and they can handle different scenarios that may exist on those machines for us. And despite our best efforts, things may well go wrong, particularly if our scripts have to deal with information that is changing and or work with networks, and therefore deal with unknowns outside of our own machine. So we need to be able to handle errors or unexpected results and do something in there. And if all of that handling and control is built into the script, then it's always handled correctly, and we aren't left wondering why things happened or why things did not happen. Another significant value of scripting, particularly from a business perspective, is to automate a repetitive task. Quite often when we have a company that has a lot of staff, one of the reasons for that large count of staff is to handle things that have to be done over and over and over and over. Whenever we're iterating through data or going through things one after another, either because we're changing them or because we are creating reports or summarizing what was there, anytime we're evaluating multiple things, we're summarizing those things or reporting on them, or making changes to files or devices or machines, and there's more than one, we might want to think about automating that. Make the machine do all the repetitive work. And of course, if we build the right intelligence into our scripts, we can deal with the things that go wrong while we are going through and looping through the different machines and looping through the different tasks and the different pieces of data, such that one error doesn't sidetrack us completely. When we're doing this by hand and something goes wrong, we have to stop, figure it out, solve the problem, and then we can go on to the next thing. Whereas a script can note that one thing had an issue and continue with all of the rest and getting them done if it's appropriate. From a business perspective, this is very important because this can save a lot of time, and of course time equals money. There is a chart on the right on this particular slide that tries to give a graphical view of this. On the red line, we have somebody who is capable of doing scripts. In the chart, they're called geeks. Derogatory term, but nonetheless, people who actually have technical skills to do things. And on the blue line, we have the person who does the manual chore, isn't very interested in making the machine do things for them. They're simply doing their job. The blue line is very simple. The person does one thing, then the next thing, then the next thing, then the next thing, until it's quitting time and they go home and do the same thing the next day. Assembly line style work. So that's a simple relationship between the amount of work that gets done for the amount of time they spend. On the other hand, a technical person who can create a script needs to start out doing things manually in order to get an understanding of the task and what might go wrong with it. Once they have that understanding, the graph says get annoyed, that might be their impetus to do it, or they may simply feel they know enough about it that they know how to automate this now, and they'll create a script. Now, while they're doing this, they're not actually doing the piecemeal work anymore, the work that the script is going to do, so they fall behind the person on the blue line in terms of work output. However, at some point, the script is done. Now the technical person can simply run the script and achieve essentially an infinite amount of work without having to spend any more time on it themselves. And they very quickly will catch up to the amount of work output from the non-technical person. This is a good graph to give the boss when you're asking for time to write scripts or to automate tasks. So these values and these things that we get from scripts lead us to the flip side of the coin, as it were. How to know when we should be writing scripts? Well, the most obvious one tends to be when we're working on multiple things. If we're doing something over and over and over, it's a pretty good bet that should be done by the machine, not by the person. It's also a good way to save complex command option combinations. If you've got a command that is a very complex command to figure out and run, and may have complex things happen with it, once you've got it figured out and got it working the way you need it to, it's a pretty good idea to take that command and shove it into a script file, so at the very least, you never have to figure those things out again. The next time you run this might not be for a week or a month or until next year, and you really don't want to start from scratch on it again. Scripts can also be used to enforce business policy. Having a user run a script to take them through a task and perform tasks for them makes sure that every step in the task gets done in the order it's supposed to. And if the script is written properly, it can even check that the correct output is produced in the correct formats. So basically, scripting is going to give tools to users so that they can do things that they wouldn't otherwise be able to do directly without having to train them to do those things. When we write our scripts, we do need to remember that the user doing this is not someone who knows what commands are in the script, and even if they did read the script, wouldn't necessarily have any idea what it's doing or how. So our scripts need to take that into account and deal with the idea that users may not understand what's being asked of them, users may not understand what data to give us, and they may not know what they need to do with what came out of it. The different shell programs we're going to use in this course come in multiple versions. The bash shell, the current version is 5. You're going to find that on most Linux systems you encounter these days. If you run into an older machine, you may encounter version 4 or even version 3. There are not a lot of differences between the versions. Linux and the bash shell have been around for a long time, and they don't change very much. Most of the distinctions between bash version 4 and 5 are purely for user interface convenience, and unless you're a bit of a bash nerd, you aren't going to even see what those differences are. Version 3 has some features missing, but you're unlikely to need them if you're working on that old of a machine. On PowerShell, there are actually 2 different kinds of PowerShell. There's what's called Windows PowerShell. There's what's called PowerShell Core. And while they are the same shell in theory, in practice, they come out quite different. PowerShell 5.1 is a Windows-only version of PowerShell, as was version 2, 3, and 4. You may encounter the older versions, 2, 3, 4, or 5.0. Any reasonably modern recent installation of Windows 10 is going to have PowerShell 5.1. PowerShell Core is newer. It is cross-platform. It's available for Windows, Mac OS, and Linux. PowerShell Core 7 may well be out by the time you watch this video. PowerShell Core removes the restrictions that are created in Windows PowerShell by the fact that it runs only on Windows. As a result, a great deal of what is in Windows PowerShell is gone in PowerShell Core, but it's available on multiple platforms and being worked on all the time to add those things back in and extend it from there. All shells do evolve over time. New features do get added, things change, features may get removed. It's really important to make sure that if your shell script depends on features that may not be present in all versions of the shell, that your shell script checks what version it's running under and either adapts to that or notifies the user they aren't running the correct version of their shell and that they need to either upgrade or use another product. For our labs, we're going to use Bash version 5 in Linux. We're going to use Windows PowerShell 5.1. The expectation is that you'll use Ubuntu Linux for the Bash portion of the course and Windows 10 for the PowerShell portion. This course is broken pretty much exactly in half. The first half of the course, we are going to be working in Linux on Bash. When that is done, we're going to work in Windows on PowerShell. We are not going to mix the two. They are quite different, and it will be very difficult to work on both at the same time. So ensure that you have your work on Bash completed before beginning the PowerShell portion of the course. When you create your scripts, you're creating files. No matter which machine you create them on, whether it's a physical machine, whether that's your laptop or a desktop computer or a dedicated machine like a Pi or a netbook, or whether it's even a virtual machine, your files will be created on that machine on its hard drive or virtual hard drive, and it will save them, but it won't protect them. So if something happens to your virtual machine, or something happens to your desktop or your hard drive, or you simply make a mistake and either delete or modify a file in a way you can't undo, then you've lost your work. As a result, we are requiring you to use GitHub to save your files and provide version history. In our first lab that we do, we're going to configure GitHub. We're going to create a GitHub account if you don't have one. They're free. You're going to create what's called a repository, a space to save your files. And all of the work you're going to do is going to be in a cloned copy of the repository. As you complete work, you'll upload it back to the repository so that when the time comes to get your work graded, I can look in the repository to see your work. And if anything bad happens on your machine, you can get back previous versions of it from GitHub, no matter how badly you've damaged your files. GitHub is a much bigger concept and product than we make use of. We use it in a really, really simple way, mostly to give ourselves backup and the ability to see the files from multiple places for collaboration in a very basic way. GitHub can be used for far, far more than we're going to use it for. When we're using it, if you find you have an interest in it or want to learn more about it, there is an ebook available. I've given the URL to you on this slide, and it gives you everything you ever wanted to know about GitHub. It's produced by the GitHub people, and it will let you move forward with GitHub beyond the simple things we do in this course. So that's a quick overview of where we're going with this course, what scripting is about, and what shells are, and which ones we're going to be using. Let's move into our first lab, where we'll set up a Ubuntu desktop machine. We'll set up a GitHub account and a repository. We'll install Git and Atom and shell check on our Ubuntu desktop, and we'll create our first script to say hello world.